Video, I'll be walking you through lessons concerning the measurement of arcs in terms of degrees and lengths, and how these measurements are connected to both the central angle, the angle at the center of the circle, and the inscribed angles, the angles whose vertex is actually on the circle. To begin with, let's take a look at something that you should be familiar with after watching and following the lessons prior to this. So I would like you to pause the video throughout this to try some of these questions on your own before I reveal the answers, and you should be okay with trying to figure out the work for example number 1. And if you can't, just leave the video on play, but pause it, of course, to try it on your own. So for question number 1, we're told that the radius is 5 centimeters, and I want to know how many degrees the circle measures, and also want to know how many centimeters the circle measures all the way around. So if you've done the question, you should have had 360 degrees and approximately 31.4 centimeters. How did I find the distance around? Well, you could just follow the circumference formula, pi times d, or you could use 2 pi r, but I prefer pi times d. If the radius is 5, then the diameter is 5 and another 5, or 10. So pi times 10 would be the circumference, or about 31.4 centimeters. The answer looks to be right, because if it's 5 from here to here, I could picture about 7 of those 5s going around that circle. Or if it's 10 all the way across, then a little bit more than 30 to go all the way around. For question number 2, it's something you should be a little bit familiar with. Maybe try those questions on your own too before I show you the answers. All right, here are the answers. When we are discussing an arc of a circle, we're looking at part of the circle. And the arc here is in red. If it's a 36-degree angle at the center, then it's also considered to be 36 degrees as the measurement of that arc. And you see how the arc has that eyebrow symbol above it representing the curved part or curved portion on the circle. So it has a arc measure of 36 degrees, which matches the central angle. In terms of figuring out how long it is, you should be thinking back to last week when we discussed the formula to figure out part of a circle when we know the entire portion of it. So in this formula here, we're going to have 36 over 360. The part of the circle is what I'm looking for, of x, and the whole circle all the way around is, well, it's the same circle as in question number 1, so it's pi times 10. So if you follow that through, you can see the 2 different ways we can measure an arc. We can measure an arc, as I did in red, as a degree measure. We could also measure the arc as a length, which in this case would be about 3.14 centimeters after setting up this proportion and cross multiplying. Again, the answer looks right to me. If it's 5 from here to here, I can totally believe, if it's 5 centimeters for the radius, I can totally believe and get behind it that this is about 3 centimeters here from here to here. And then a quick vocabulary check, that angle there in the center is called the central angle. All right. Now on to something that you completely haven't seen yet, I suspect, which would be what an inscribed angle is. So let's look at this one. Fact number 3 concerning circles. Inscribed angles do not have their vertex or their tip on the center of the circle, but on the circle itself. So in this picture right here, the central angle is CAB because its vertex is right on the center of the circle. In this question, it's telling me that CB is 66 degrees, So how many degrees is the central angle? It would have to agree. I think that I've got that on the next slide. Now the inscribed angle is this angle here. If this angle here is 60 to 66 degrees, just by glancing at it, I hope you can see that this inscribed angle is going to be less or more or the same as this angle here. Hopefully you look at that and say, yeah, that's closed up more than the one over here, so it's definitely less. And as it turns out, it's half as much. So the central angle is 66 degrees as well. If it's 66 degrees for the arc, it's also 66 degrees for the central angle. Now the angle that's inscribed in green here would be half as much, 33 degrees. And I'm going to show you why in just, or give you some confidence that that's correct in just a second. Before we do that, if you're following along on your worksheet, you could write down the fact that inscribed angles are always 1/2 of the central angle, and inscribed angles are also 1/2 of the arc. So 66 degrees here, these would match. 1/2 of 66 is 33, or you could go 1/2 of this 66 is 33. So here's a quick demonstration on GeoGebra showing you that that's the case. So here's an example of the arc measure equaling the central angle, and the fact is that the central angles always equal the measure of the arc. The nice thing about GeoGebra is I can actually move these points and change the angle itself, and you can see every time I'm opening up that angle, the arc is opening up the same amount of degrees. So if I'm at a semicircle, 180 degrees as the center angle, but also 180 degrees of the circle. If I make a right angle out of this, make a quarter circle, it's 90 degrees as the center angle. It's also 90 degrees along the arc. And it doesn't matter the size of the circle either. When we're talking about the measure of the angle, we're not talking about how long it is on the circle as a length. We're looking at how many degrees it makes up out of the 360. And of course, I can open up even more than 180 degrees and get to the point where I get really, really close to 360. Yeah, there we go. And that would be the full circle. So the central angle always matches the degree measure of the arc. The second fact, that the inscribed angles are always equal to half the arc, or the inscribed angles are equal to half the central angle. Here's one example where the inscribed angle, the angle that has its vertex or its tip right on the circle, that's half as much as the central angle and half as much as the arc that's being swept out. So here you can see 180, 180, it's a semicircle, and that looks to be a right angle. So no matter how I move this angle around, something called Thales theorem, that if you have a semicircle and you have an inscribed angle that opens up to that semicircle, no matter how you move this angle around, it'll always be worth half as much as that semicircle, or 90 degrees. And I think that's pretty cool. And that's why I'm showing you this on GeoGebra, because I can show you many, many examples all at once. Now, when I flip over here, it actually gives the angle measurement on the outside of that triangle, but still a right angle no matter how I'm swinging this. So that's an example of an inscribed angle. And to show you that that would work for any inscribed angle, let me open up to, well, we'll pick 140. We'll pick something even. There we go, 140 degrees. You can see that it's 140 degrees is the central angle. The arc from DF is also 140 degrees. And no matter how I move point H, it's always going to be 1/2 of that 140 degrees. Well, it has to do with the fact that there are some isosceles triangles in this picture. So I'm starting off with this example here. You can see that the arc here, or the central angles in red, is 180 degrees. It's 180 degrees on the arc. The central angle in red is 180 degrees, but this blue angle here is half as much. 45 and 45 make 90. If I'm looking at that blue angle and moving point K around, no matter how I move point K, I'm always getting that those two angles together match up to, well, with some rounding maybe aside, always add up to make 90 degrees. Like for example here, this 20 and the 70 makes 90, half as much as the 180 degrees. By drawing this extra line in here too, I'm creating two different isosceles triangles. So the reason why it's half as much has a lot to do with the fact that there can be isosceles triangles that are drawn in there. And just to show you how I can change that red central angle into something different, let me just pick 100. It's a nice number to pick. 100-degree angle. Whoa. So if I got a 100-degree angle, that blue angle should add up to 50. Both halves here should make 50 degrees, no matter how I move this about. So there's 20 and 30. If I make one angle 3 degrees, the other one's got to be 47. If I make one 10, the other one has to be 40. Together, the two blue angles here, or the two angles here that form this blue angle, have to make half as much as the red angle. And that's something. There's some things that you should pay attention to when it comes to working with these angles. One is pay close attention to whether or not you have a semicircle. So sometimes you might not see a number in the question that you're working with that you'll need, and just be on the lookout for anything that's a semicircle. It would be 180 degrees as the center and 180 degrees as the arc. Another thing too that occasionally comes up are these isosceles triangles that can be drawn. Since this triangle here is made up of two sides that include the radius for one of the legs of the triangle and another radius as another leg, it's guaranteed that these two sides are the same because they're both radii of the circle, which would mean that both of these angles here would have to be the same. So that's something that creeps up occasionally that might catch you off guard. Now let's actually dig into some of the practice together. I'm going to start the homework with you. For question number 1 on the homework assignment, it says it's 113 degrees for the arc measure, and they want to know what the central angle is worth. So if you've been following along pretty closely, you already know the answer. The central angle has to agree with the measure of the arc. In question number 2, we're looking for the measurement of x, and x is not a central angle. X in this case is an inscribed angle. So if we've got 124 degrees on the circle for the arc, the inscribed angle would be half of 124. So 62 degrees for x. Just showing you a few more examples here. I guess maybe just 3 more examples. For question number 3, the picture's slightly more complicated, but we're still following those same rules. If it's 162 degrees as the central angle, we know that the arc LM is also worth 162 degrees, and they're looking for the value of x. So they want to know how many degrees is in this red angle here. Well, that red angle is not a central angle. That red angle is an inscribed angle. So the value of x would be half as much as that 162. So 81 degrees for angle x. Question number 4, maybe you're thinking, hey, this is easy. I think I got the hang of it. Question number 4 is actually a really cool one because it looks a little bit more complicated, but it's really just as simple as the other examples. They're telling me that angle K is worth 25 degrees. So let's do a vocabulary check. What type of angle is angle K? Is it an inscribed angle or a central angle? Well, central angles have their vertex at the center. This is an inscribed angle because its vertex is touching the circle. The word inscribed makes me think of the word inscription. If there's a piece of jewelry or a statue that's inscribed with something, It's actually something that's written or carved into the metal or the stone. So that's what I usually think of when I think of inscribed angles, is they're scripted into or etched into the circle. So if it's 25 degrees here, that's going to be half as much as the arc over here. So the question is, how is that going to help me, knowing that this is 25 degrees on the circle? I'm sorry, 50 degrees on the circle, twice as much. So how could that help me figure out the answer to my question? Well, I'm looking for angle X. I'll trace that over in green. So forget about the angle in blue. Now let's focus on the angle in green. What type of angle is that? Inscribed or central? Well, its vertex is right on the circle, so it's inscribed. So that inscribed angle would be half as much as the arc. So the answer there would be also 25 degrees. What's kind of cool on a question like this is you can add more and more inscribed angles. I'll do one in yellow, and every time I do an inscribed angle that touches that part of that arc between I and H, I'll always get 25 degrees. So as it turns out, I mean, I can change some colors around here to make it even more pretty, but no matter how I draw an inscribed angle, I'm always getting 25 degrees every single time. So I could be adding on more and more colors here, because maybe there's more ways to get more colors on this thing, but we'll just go with red again. Of course, if you're drawing with straight lines, it actually helps out quite a bit as well. So more and more of these inscribed angles can be actually drawn in. But every time I make an inscribed angle to that 50-degree arc, getting 25 degrees. So you get some really cool pieces of art. It almost looks like something called string art. All right, looking at question 5. Well, let me drop some more vocabulary on you right now, too. So one thing that I did not mention yet is the word chord. A chord is a segment that connects one part of the circle to another part of the circle. A chord could be the diameter of a circle, but a chord goes from on the circle to right back on the circle. So as we have here, we have a 4-sided shape, a quadrilateral formed by 4 chords. That forms something that's called a cyclic quadrilateral. And a cyclic quadrilateral has 4 inscribed angles. In this question, it's asking me to determine the value of X if the arc TSR measures 122 degrees. They've helped me out in this question by putting the 122 into the picture. And the arc that they're talking about goes from T to S to R. So I'll highlight that in yellow. That arc TSR is worth 122 degrees. Sometimes when you measure an arc or describe an arc, you want to use 3 letters. Notice if they just called it TR, if they told me that arc TR was 122 degrees, I guess I wouldn't be 100% positive that they meant from T to R this way or from T to R this way. I guess this is the minority of a circle, not the majority of a circle. So if I had to guess, if they just told me TR, I would guess that was going this way. But for clarification, sometimes they add a 3rd letter here to help you decide which way the arc is traveling on the circle. All right, so I'm after that angle X here, this inscribed angle, and I've actually given a hint. To figure out the measurement of this angle here, I could find this arc first, TQR. So how am I going to get that? Well, remember that a circle has how many degrees total? 360. And if the yellow arc was 122 degrees, the remaining piece would be in black. So you can use a calculator for this or do it by old-fashioned arithmetic. So 238 degrees is this outside arc measurement right here, 238 degrees. The angle inside here, this angle which I'll highlight again in black, is going to be half of that black arc. So 238 divided by 2 would be 119 degrees. And again, a nice visual check is nice. I mean, we all know what a right angle looks like, 90 degrees. This is actually looking like a little bit wider than 90 degrees, but not completely ridiculously wider. So it's just it's opening up just a little bit more than a quarter turn. So the answer looks right. I've given you a head start here on the homework. If you got question 6 to do, and then we've got actually it looks like a lot of work, but I'm giving you a lot of small questions here just to build up your skills. So there's at least maybe 30 different circles to take a look at, for homework, and do your best with them. I mean, some of the questions are asking for more than one piece of information. I guess keep in mind that a circle has 180 degrees in it, so those sort of things can really help out sometimes in trying to figure out things. So it's 180 degrees on that circle here. If this is 50 degrees as the central angle, I know that it's 50 degrees on the arc. So that means that this part right here would have to be the remainder, which is 130 degrees. So those sort of thoughts can kind of help you figure out the mysteries of what's happening in the circle and on the circle. So I know it's 130 degrees here. I've got vertical angles, so that's 50. And then I've got one missing angle right here, and I'm not even sure what the questions are asking, but it's that sort of thinking that's actually going to get you through some of these harder questions, or the ones that have more little bits and pieces to it. All right, so that's the end of today's lesson, and we'll be continuing on with angles in and around and actually outside the circle coming up soon.